Welcome to our talk. Hope you had a good lunch. I am Ashish. I am a solutions engineer at Okta, and with me is Shivay. He's a developer experience engineer at Couchbase. And today we are here to talk about the missing piece in agentic AI security. Like the potential of AI is just increasing day by day, but as we say, with great power comes great responsibility. But here also comes a much greater and much significant risk. And in today's talk, we are going to address that part. So Shivay, can you tell people about what is the agentic AI space looking like?
Yeah, absolutely. Thank you so much, Ashish. So we have already seen a huge uprise in adoption of generative AI. And if you look at the entire AI landscape, it has grown quite considerably in just a very short period of time. Right from the early 2000s when we were just starting with these language models to now full-fledged agentic AI where you can have AI agents take complete control over tasks and do things that we could have just dreamt of is now possible. Now, of course, we have seen that this huge influx in adoption of AI has taken up really quickly, and we are truly seeing the true potential of AI. And you have already seen at KubeCon how quickly a lot of companies are adopting AI. But of course, with that kind of an adoption, there are also some impending security risks that you have to be aware of. And of course, today in our presentation, we're going to be covering that. Now, of course, just a basic primer on generative AI. So, of course, we know that generative AI means these type of hyper-specialized AI models that can create content for you, such as text, images. So, for example, you could just ask an AI model to generate a spreadsheet for you. Of course, the way that you interact with these generative AI models is with the help of prompting, which is not having to write code, but you can just interact with them in your natural language and do things like, hey, can you please summarize the sales call for me? Now, of course, we are seeing AI agents, and they are these AI-powered assistants that can leverage these tools in order to run tasks for you. So, of course, at the power of running these agents is LLMs that now can understand human input and now go ahead and run tasks for you. And finally, we have Retrieval-Augmented Generation, which means that how AI LLMs can basically enrich their own data by using some sort of data set that you have provided to it so that you can enrich the context of these LLMs and give it more factually correct responses. But of course, there are certain gaps. Now, of course, as we understand that how AI agents basically work, there are two aspects to it. The first one is that the agents are able to understand the user's input. Now, typically the user's input will be a lot of unstructured data. So we have the agents handling this unstructured data for us, then evaluating it and identifying what set of tool it should use in order to run that particular task. And then, of course, as we know that agents have these set of AI tools that they can leverage, whether it's calling an API, accessing a database, or running completely autonomous without any human input. Now, while this is great, there are some really interesting security concerns that we are going to be talking about. And we have already seen some of the leading professionals from CEO of Salesforce and some of the other folks who have concerns about AI and agent security with the proper authorization that needs to be put in. And that's what we'll address in today's presentation. So going over how, how all this landscape kind of comes together. So some of you might have heard of OWASP. So OWASP provides a set of tools and regulations around security. And since the last couple of years, they have been focusing on LLMs as well. So these are the top 10 LLM-based security best principles that need to be aware of if you're implementing LLMs inside of your applications. Now, we're not going to be focusing on all of them because as AI application developers, we are in control of some of them, but not all of them. But that is the majority of them we are going to be in control. And if you look at the ones that are marked in red, all the way from sensitive information disclosure or improper output handling, these are the ones that we as AI developer engineers can basically be control of. But of course, the other ones like prompt injection are more AIML specific. So we're not going to be focusing on those. In addition, there are also some security concerns that a generative AI agent must basically address. Now, starting with, it should be aware that it should only be interacting with users who are authenticated so that it can basically do user-specific interactions. Then, as we know that agents can do tool calling. So we need to ensure that there is proper authorization and authentication being put into place to ensure that these API calls that are being made, they are being made in a secure manner. And at the same time, there might be some long-running concurrent tasks. So the AI should be able to use async interactions. And most importantly, AI data access must consider user permissions when accessing data. And I feel like this is one of the most important parts and the main crux of our presentation around user permissions, because there are so many different companies that have really private and compliance data. So we want to have complete surety that only people with the right kind of access, with the right authorization, can actually access those particular documents in order to prevent data leakage. So that is why our talk is going to be focusing on this part of sensitive information disclosure, where the entire idea, as I kind of shared in the last slide, is that when any user is interacting with an AI agent, it is only ensuring that we are only giving it information that is accessible, or what information is authorized for that specific user, so that we don't give any unauthorized access to the LLM in order, because there might be a malicious attack, or the LLM might accidentally give out these type of details. So let's also look at a practical example. Let's say that your company is building an AI agentic solution for its internal knowledge base. So the AI agent can only access the company's public records unless explicitly authorized. And it should also ensure that the AI agent should not access some confidential record that belongs to some other solution, right? So how can we ensure this type of private access to information and ensure that there's no leakage of the data at runtime? Well, the answer to that is authorization. So we'll be learning today how we can implement authorization for AI agents and ensure that only the users that have specific authorization permissions can access that specific documents. And of course, in order to go more further, I'll let my co-presenter Ashish take over.
Thank you, Shivay. All right, so authorization is the missing piece of the puzzle, but to get to the authorization for agentic AI agents, let's take a step back and see how authorization has evolved over the last few decades, and what methods have we already tried, what we are already having implemented in our non-AI applications, if I can call it that, and let's see how we can translate those over to our agentic AI apps. So it all started back in the 80s when we had access control lists. That was the first type of authentication, and it was very primitive. There were read, write, execute commands that you had, and it was basically answering simple questions like, does Kate have read access to this file? If yes, she has access to do anything with the file. If she doesn't have access, no, she cannot read it. As simple as that. And after access control list, we had role-based access control. Now, this is one of the most prominent ways of maintaining access that people use in their applications. And role-based access control depends upon different roles. And these roles are generally groups in which you can distribute people into or resources into. It could be, an example could be there is an engineering role, there is a designer role, there is an admin role, finance role. So you can define 10, 15, however roles you need for your company, and based on that, you can assign them application, you can assign them documents based on that role. So if Kate is in the product manager role, she should have access to all the documents which are in the product folder. So role-based access control works like that. But the downside of a role-based access control, or RBAC, is that what if you have a lot of roles and they keep changing? And essentially, to implement these role-based access control checks, you are writing if-else statements throughout your application layer. So you will be checking if role equals product manager or roles equals engineering, then give access to this document. But let's say you want to add another role to that check, like if a roles equals design, they should also have access to that document. Then you need to go and check out all the different instances where you have that check and implement those changes there. This can cause scalability issues and can also lead to inconsistencies, where you might just leave out some check and the person who is not intended to see that document is still having access to that document. So this is one of the downside. And these two methods are kind of coarse-grained authorization, where we are just leveraging a single attribute to make the authorization decision. What is better than this? Fine-grained authorization, where we leverage a combination of multiple attributes to come to our authorization decision. And one way to implement authorization leveraging multiple attributes is called attribute-based access control. Here we are checking based on different attributes. These attributes could be the role, let's say, the department, the working hours, the IP address, anything which can be identified with that specific user or resource. So in this example, we are checking, is Kate in the product department, and is it working hours for Kate? We can also check, is Kate accessing the document through the company IP address or the company VPN. So we can check all these attributes. If all of them answer to yes, then access control is provided, else the Kate is not allowed to access the document. What is even better way of doing authorization? Fine-grained authorization. And that is implemented through something called as relationship-based access control. Where attribute-based access control fails is, let's say we have a document which is inside a folder, and that folder is nested in another folder, and that has another folder on top of that. So 3 layers of folders, and within that there is a document. Now, we need to check if Kate has access to that document. For that, we will first check her access at the top level, then 1 level below that, then the second level, then finally check access to the document. While doing that, if she doesn't have access to that specific document, we wasted like 3 database queries on checking the previous 3 folder relevance. So in that case, we are querying the product database, we are wasting our queries, which might lead to latency in your other core product feature queries. This is where ABAC fails, that you cannot directly check for the document. But if you implement relationship-based access control, there is no hierarchy per se here, but you define one-to-one relationships here. So you directly define, like Kate belongs to product department. Then separately, you are defining that this document belongs to product folder. And again, separately, you will define that Kate should have access to product folder. Nowhere we will define that Kate should have access to this document. But through the different 3 definitions we had, it will automatically generate a graph, and when we check, does Kate have access to this document, it will inherit those relationships between all these 3 elements, and finally give access to Kate for that. This is way we can leverage multiple attributes and give Kate the access she needs. So, based on our discussion, which authorization system works best for AI apps? It's Reback, because it's based on fine-grained access control. All right, so how to implement Reback? For that, we use something called as OpenFGA. OpenFGA is a solution which is owned by Cloud Native Computing Foundation, and it is being maintained by my company, Okta. There are a bunch of great maintainers from other companies as well who actively contribute to this solution. And OpenFGA is also used as the core of Auth0FGA, which is a managed offering by my company. It is mostly needed when you need SLAs or high availability rates and all that. But the open source version is free to use, and it can be deployed on your own premises using Postgres, MySQL, SQLite, whatever you want. And OpenFGA was inspired by Google's Zanzibar paper, which describes how authorization for all of Google services are built. So if you have worries about scale, just think Google Drive, Google Docs, all these services operate on top of something like OpenFGA. So they work on relationship-based access control. So there is insane scalability there already. All right, so where does fine-grained authorization lie in the whole authentication pipeline? So this is an example of how you will build authentication and authorization for your existing web application. There will be a user who tries to log in using some identity provider. It can be Auth0, it can be WorkOS, Clerk, Keycloak, any open source, any provider, doesn't matter at this point. Then an access token is generated, and then they have access to the application. After that, they will try to access some APIs where you have some checks based on RBAC or any authentication-based checks. You will do some logic and finally give them access or deny them access to that API. But this is happening all in the application layer. So everything is making requests to your product database, and everything is there. But when you implement FGA, then the first part remains the same. Access token is generated, and then finally you have the time to query the API. At that time, you will call another API which will just check for authorization, which is completely separate from your existing application. It will be a central database where you are just checking, does Kate have access to this document? If she has, allow her to access the API. If she doesn't, just throw a forbidden error at that time itself. All right, so yeah, these are some of the secondary benefits that you get with implementing something like relationship-based access control. You can seamlessly manage authorization for all your applications at one place. Like if you have a mobile app, a web app, rather than managing authorization in both those apps separately, you will have a centralized place. And this helps with auditing and compliance purposes as well. Like you can check the trails where something went wrong. And if you are adding a new product, it makes that easy as well. Cool. So how does OpenFGA work? Essentially, there are three key elements. There is an authorization model, there are relationship tuples, and then there are access control checks. So the authorization model, in that we have a schema. There we define the key elements of our model. So from our example that we were running with, we have a user, we have a document, and the document has a bunch of different definitions, which are the parameters a user can have. Like the document can have a parent. A parent can be a folder. So a folder will include a document, so that's why we have that relation. The next relation we define is the owner. So every document will have an owner, and its type will be a user. So someone will create that document. He will be the owner. And the third relation that we define is a viewer. So from our use case, there will be a viewer as well. Now, the viewer can be just the user. We can directly assign someone to view the document, or it can be the owner. So everyone who owns the document, they must have a viewer relationship as well, because they essentially own the document. Or the third one, this is interesting, they can be a viewer from parent. So every document has a parent, which is a folder. And if you look at the next relation, there is a viewer inside folder as well. So everyone who has viewer relationship with folder also has viewer relationship with all the documents that are inside that folder. So this is what we were defining in the previous case. Now, this is our authorization model. Think of it as a database schema. So we defined that. The next thing we need to define is the data inside that model. So this is how we define relationships. User Kate has viewer relationship with the folder product, and folder product has parent relationship with the document roadmap. Now there is a user John, which we have directly assigned as a viewer to the document roadmap. Now, once you have fulfilled the data, the next thing is just checking if everything is working all right. So we write assertions, like, does user Dave have viewer relationship with the document roadmap? Since there is no user Dave in our relationship tuple, this will result as false, as expected. Then we check, does user John have a viewer relationship with document roadmap? Since we have specifically told the tuple that there is an existing relationship, it will return as true. Lastly, we will check for Kate. Does Kate have a viewer relationship? We will leverage like two separate tuples in this case, because there is no direct relationship. And based on this, OpenFGA will automatically inherit the graph and make the decision that this should return true. All right, so now it's time to show you a demo of how it will look like in a production use case. And with that, I will hand it over to Shivay to explain the architecture.
Yeah. So first, let's take a step back and revisit RAG, right? So we spoke about Retrieval-Augmented Generation. Now, just a quick vote. How many of you know about RAG? So see quite a lot of folks. For the folks who don't know, so of course, as we mentioned, RAG is Retrieval-Augmented Generation. The entire idea is that, as we know, that AI models are trained up to a certain period of time, and if you are asking it questions about something that has happened post the training period, then it will hallucinate and it will give you an incorrect answer. So what we identified was that, okay, a great way of being able to mitigate this particular issue is that if you have a knowledge base or a database, you can store your data as embeddings, right? And you can now retrieve these embeddings based on a user's query, where you convert the user's query into an embedding. You perform a vector search with these hyper-specialized databases, which are called as vector databases, where you store the original content and the embeddings, and you retrieve the most relevant set of documents based on the user's question. And now you pass on these list of embeddings or the embedded documents to your LLM to augment its response so that it can give you much more accurate responses. So when we talk about RAG, right, a lot of companies are using it for internal knowledge bases or maybe customer support, where your chatbot can probably, like, let's say, look back at some of the previous ways in which previous particular customer queries were resolved, and they are looking back at the resolution steps so that they can give resolutions to the real-time customers. And that is why I think OpenFGA or authorization is such an important aspect of RAG, because you want to ensure that in case a user is going and asking an LLM a really like an important question, the LLM does not just hallucinate and give a response based on certain documents which were not authorized to be viewed by that particular user. At the same time, we are also involved with risks such as your prompt injections or hallucinations, where your malicious actors can trick your RAG pipelines to be able to get proprietary data. And that's why I think like OpenFGA plays a really important role for securing your RAG pipelines. So in our demo, what we have done is that we took a bunch of documents. We first chunked them, which means breaking them into smaller text. We used an embedding model like, let's say, OpenAI text generation LLM model, or you can use any open source model as well to generate the embeddings. And then we store them into this hyper-specialized vector database like Couchbase, which is built for performance. And now what we do is that when it comes to the retrieval, we send the user's question, convert it into an embedding as well, and then we find the most closest set of documents which are most closely related to the user's input query, and we pass them to the LLM to get a response. So in our case, if you want to make it more secure, one way is this post-filtering effort, where the user asks the question, then we follow the retrieval, where the LLM or the vector database is now sending you the list of most important embeddings, and now the LLM has access to them. Now, this is where we'll apply the filtering that my co-presenter Ashish explained with the help of OpenFGA to ensure that only the set of documents which are accessible to this user based on their permission. So we'll be able to filter these set of documents, and the LLM will give a response to the user. But this particular process is still not 100% secure because of the fact that the LLM is still getting access to all of the documents, including the ones which might not be authorized to be viewed by that specific user. So this is where you can also apply pre-filtering. So what that means is that as soon as the user asks a question, of course, we'll know which particular user is asking that particular question, and we'll be able to use the OpenFGA filter to filter out the documents based on the user's permission, and we'll pass this to our vector database in our query that only access these specific documents because these are the ones that are authorized to be viewed by this user. And then we'll apply our vector search to retrieve the set of documents that are, of course, already pre-filtered out, and then the LLM only gets access to those particular documents, and it gives a response. So this pre-filtering approach, of course, makes it a lot more secure because you're already filtering the set of documents before your retrieval step. So how does that particular RAG pipeline look into our actual application? So here we have, as we mentioned, an internal knowledge base where the users of a company want to see the forecast for it. So here you'll see at the top, you have any user. They ask a question such as, what are the financial projections for this year? Here we are using the pre-filtering, so which means that we get to know this is the user, these are the set of permissions that they have, and the set of documents that they can view. And we filter out those documents with the help of the pre-filtering. We use our vector search, again, with the help of that particular document. So here, that's the user query. We use the OpenFGA SDK to enforce the authorization rules so that we get only the list of documents which are permissible to be viewed. And finally, now we perform the vector search with the help of a database like Couchbase. And once we have got these responses, we augment the LLM. In this case, we'll show a use case of OpenAI, but you could use any open source model, including the latest OpenAI models that have been released from OpenAI for Hugging Face. And finally, the LLM will be able to generate a response. So now I'll let my colleague Ashish now talk about more of hands-on demo for this particular use case.
All right, so for our demo, we will be using OpenFGA Playground. This is a website, again, developed by Okta, but no sign-up is required. You can just go to this website, start playing around with existing models, create your own schema, your own tuples, everything, and use it as a learning tool because the data you put in here, in the tuples and everything, it is only stored in the browser, so you should not use it for production. And for today's demo, I have just used that because it's just a learning thing that I'm going to show. All right, so let me just bring it back. Yeah, another thing, this is how our authorization model looks for today. So this is similar to the example I showed you earlier, but now we have defined a bit more of the relations for the project. Project is essentially the folder, you can think of it like that, and the document has an admin, editor, viewer, public, a bit more relations. So let's see how this looks like when we integrate it with an actual working chat application. Okay. Yeah, this is a chat application which is powered by OpenAI, and it has a bunch of different documents, like there is an architecture document, there is a design document, there are financial data, there are public APIs, and all of these have been chunked and embedded. And in our demo, we have 4 different user personas. There is a CEO, there is a lead developer, there is a junior developer, and there is a salesperson. And all of them have access to different number of documents. Like the salesperson only has API, public API access. The lead developer has public API, design access. The CEO has access to all the different documents. And now, in our example, what we will need to see is that when we ask a question, how does the responses differ when different people ask different question, the same question. So let's ask the chatbot to give me a full summary of Project Odyssey. And the CEO will receive data, which includes, let's say, the financial projections and the other details about the project. But since the salesperson doesn't have access to the financial data, when he asks the same question, he should not receive any information about the budget and everything. And the AI can reply like, as for financial performance, I don't have access to that data based on my current permissions. In the same way, I have a compare view where I can ask the same question to all 4 people at once, and this is where we will see how these responses differ. So let's say I ask about UI UX guidelines. Only CEO and the lead developer have access to the UI UX documents. Okay, so the first 2 get the response about the UI guidelines, but the junior developer and the salesperson, they don't get much data. Like the salesperson is getting data from the public API documents, but the junior developer doesn't have access to it. Let's say we ask a more specific question, like what is the color palette for the project? Now, again, CEO and lead developer gets the color palette, blue, green, gray, but the junior developer and salesperson don't get the data for the same question. And let's try one more thing, API endpoints. Let's try the API endpoints. There is a public API which is available to everyone, but the lead developer has access to internal APIs. And lastly, the financial projections. So the financial projections are only available with the CEO. Now, what would happen if FGA is not enabled on this chatbot? Let me show you that scenario. In case you don't apply FGA, your LLM has access to all the different documents that are present. And in that case, if you ask this question, everyone, including the salesperson, the engineers, everyone will have access to all the numbers that your company is doing. This is where the power of OpenFGA helps add security to your RAG pipeline and help solve the top issue in the OWASP list, which is information disclosure. All right, Shivay, you can wrap up the session now.
Yeah. So as we come to a conclusion, right, of course, we just spoke about RAG pipelines, but you can also apply this OpenFGA principles for AI agents as well. Because as we know that AI agents go one step beyond just beyond like, the information retrieval. So we also have a bit of tools and resources that all of you can refer to. First one is that if you're trying to build with OpenFGA, there is the list of SDKs that you can use to develop applications. We also have a VS Code extension. There is also CLI that you can use to very quickly create your OpenFGA principles. Another way is that, of course, we saw all of these great things that you can do with OpenFGA. There are a lot of developer-friendly APIs for writing OpenFGA principles, and you can follow the API documentation for the same. So as we conclude, right, we have seen that AI is great, but it also introduces a number of different security risks, primarily focusing on the unauthorized data access. And if we go one step beyond for Agentic AI, since AI agents are also working with a lot of different tools, if a company is like, let's say, working with a bunch of different tools, you want to ensure that you can add proper authorization on which set of tools in an agent can be accessed by certain users or the user groups in the company. So you could also apply OpenFGA for defining these permissions and how the agents is able to access your documents or any other API calls based on proper authentication principles. And for this, you can also pair up OpenFGA with open source tools like DeepSecure to be able to make your overall AI agent pipelines more secure. So what we saw with OpenFGA is that it makes your AI models and agents more secure. It also makes them scalable, because imagine that right now you have 50 users in a company, you scale it up to 500 users, then you want to ensure that you can apply the same set of principles and have the secure data access even at scale. And that's where OpenFGA is a really developer-focused, friendly way of being able to apply these principles for security, both for RAG pipelines and for agentic AI use cases. And here are some of the resources, what we covered, including a sample code for the presentation that we gave. So feel free to have, image, you can take a grab of all of the different resources, including the Discord community for OpenFGA. And finally, if you want to continue having discussion with us, we'll be here around at the conference. You can also connect with on us on Twitter or LinkedIn. And thank you so much for being a wonderful audience.
Thank you.